6 4.
Oh yeah.
Yeah. 6.4 inches.
Okay. So we are skipping 6-3, so go ahead and get out 6-4. We're not going back to 6-3. It's like, it would take like 3 days to get really good at that, and it's like very, very rarely. It's just not like worth it. So we're going to skip it and go to 6-4. So I might need some help on this actually. Like knowing what I know how to do it, I can teach you the stuff, but I'm not sure what he put in each space, so I might ask you like for help along the way. Alright, let's say an interval starts at A, but we don't know where it stops. So let's say, for example, I had this situation, and this is A. But then I don't know where it stops. So this X could be there, and I'm finding that area. Or this line can like slide over, and I'll find more area, or slide back, and I'll find less area. But by calling it X, you're kind of leaving it open. There's no fixed endpoint, you're leaving it open to move back and forth. So I think that he's going to say A to X here. And then we can represent that as a new function that looks like this. So if I wanted to find the area between A and X, how do we find area? We integrate. So how do we find slope of a graph? Oh, I didn't ask that right. How do we take the derivative of a graph? Find slope. How do we find the integral of a graph? God dang it! How do we find the area of a graph? Integral. Should I go through that again? Or you guys? I'll probably just make it worse. Yeah. All right. So I want to find the area, so I'm going from A to X, and then because these are x's, whatever we call this function can't be an x also, because then you get like two variables that mean the same variable means two different things. So usually they use t, but it could be really anything. And then what that means, like if we use this simply, we have that. I briefly showed you, but not okay. So f of t, or any function, f of t is the y value, isn't it? Like if I said, let's say f of t equals t squared, and I said find f of 3, you would get 9, and isn't that 9 the y value? So this is the y value of your rectangles. But we're going to have infinite rectangles. So this is the height. This is the x value, or the width. And what we're doing is finding the sum. So this is like a stretch, it's like an S that got like stretched vertically. So this is the sum of all the rectangles that we put from here to here, but there's an infinite number of them. So this width is a very, very small number. It's like approaching 0. It's a limit as x approaches 0. And then you just have like, this is just base times height. Looks way more confusing. The base is going to be like the width of each rectangle, but again, we're going to have infinite rectangles, so the width is going to be not 0, but approaching 0. And then the height is what you get when you plug in. So this is really just base times height. Looks a lot more confusing than that, but you'll get used to it. I'm getting a little bit far off topic here, but that's okay. Alright, so if I look at this table, glad that he did this. This just allows us to plug in different numbers for x and see what we get. So if I plugged in 0 for x, so if I said like find f of 0, that would be the integral from 0 to 0, because this is the x. So whatever number I plug in, I put in that spot. So that is saying, so again, this is your base times your height of all of the rectangles that go between 0 and 0. Well, what's the area if I go between 0 and 0? There's nothing there. It's 0. And then I'm just going to change this to fill out the table. So if x were 1, I would put a 1 there. And then I would go over to 1 and find that area. And they made it like friendly shapes so we could do it just kind of geometrically. But wouldn't that be like 2.5? If You got 1 box, 2 box, 2.5. Well, so as I go to the right, I keep the area that I had, and I just add or subtract to it. You're accumulating. Like as you go, you're adding more area, or maybe subtracting it if you're below the axis. But you're just like gathering as you go. So if I put a 2 there, I've already got this is 2.5. And then I added, this is 1.5, right? So by the time I get over to 2, I've got a total area of 4. So it totals as you go. So if I put a 3, now I'm going over to here. Well, I've got 2.5 there, I've got 1.5 there. I keep those and I accumulate as I go. So I just add that 1. And so what would go here? It's 5. Does that make sense what I'm doing? Yes, no. Yes. So if I go over to 4, if I've made that a 4, I keep the 5 I have and I add another 0.5. So now I'm at 5.5. And then if I go all the way over to 5, now this is a 0.5. But what is this? That's a negative 0.5. So we've got 2.5. When I go to here now, I've got 4. Now I've got 5. Now I've got 5.5. And now I'm back to 5 because I got to subtract that 0.5. So you can actually look at it like this is the. I don't want to get there. Never mind. I don't want to go there yet. Does he put like accumulation function here? Accumulation function because we're accumulating as we go. Accumulating just means like totaling up or adding up all the things. Questions there? Okay. So this is actually the fundamental theorem of calculus. All it says is that derivatives and integrals are opposites. So if I had a function and I took the derivative of it, and then I took the integral of it, I basically with some slight tweaks that we'll talk about, I basically be right back where I started. So it's just like adding and subtracting, or multiplying, dividing, or squaring and square rooting. Derivative integrals. In fact, I think he uses, I saw this, so this is called, you can put antiderivative here. Sounds very like confrontational. Or integral. Those are the same thing. It's like a political stance, like I'm an antiderivative. And then derivatives and integrals are, you could say opposites. Probably more technically correct to say inverses. But the general idea. So the fundamental theorem of calculus says that this is basically saying I start with f of t. So I've got some function, t squared, let's say. I integrate it. And then I take the derivative of it. So what's going to happen to the integral and the derivative? They're just going to cancel out. So you basically end up with f of t. The only thing that does happen is we put that variable in. So this is just going to be f of x. Is that what you put there? So we'll do a couple practices. That seems a little weird at first, I'm sure. But he's basically saying the fundamental theorem of calculus basically says derivatives and integrals just cancel. And then whatever variable is up here, we plug in. A more difficult or confused, I'm never going to use this one. I'm not even going to show it because I think it's like getting to a specific case that we don't really need to look at a specific case. And let's look at this one. So sometimes there's just like numbers and letters up there, or numbers in a variable. Sometimes there's functions. So now we got a function here. So there's a chain rule piece here that happens. The derivative and the integral, these two things still wipe. but you got to plug in the top, so it would be f of g of x, and then you multiply by the derivative of what you just plugged in. Well, does that look familiar? What is it? That's chain rule. So you're doing chain rule by plugging in the top, and then you're going to subtract chain rule plugging in the bottom. This will get, I have a feeling this looks like crazy difficult right now. It is not. When I show you examples, you'll be like, oh, that's it. But I have to write out like the formal thing that's going on. So this would be f of h of x times, can anybody tell me? H prime. There is a chain rule piece there. I didn't have to write the chain rule piece up here. Like, I just use this every time. I don't ever look at like this specific case. I don't even look at this specific case. I use that on every one. So I could use it up here also. So this is telling me plug in the x, which gives me f of x, right? Times the derivative of x. What's the derivative of x? 1. Minus, now I plug in the bottom, so I get f of a, times the derivative of a. Well, a is just a constant, so what's the derivative of a? It's 0. So, don't I basically just end up with this and none of the rest of it really matters? So like I just use this every single time. I'm showing you, this is the fundamental theorem, so it's just saying derivatives and integrals are opposites. It's important to understand that. But I don't really use that formula. I just do this every time. So let's start looking at a couple problems. It's not just F's and G's and H's all over the place. So find number 1. So my job on every one of these is to plug in. So it's like f of the top times top prime minus f of the bottom times bottom prime. It's not like super formal, but I think that's the way it's easiest to think about it. So by like number 1, when I plug the top in, and you plug it in for t, that would just give me 3x squared plus 4x, right? So that's plugging in the top, 3x squared plus 4x. But then I got to multiply by the derivative of the top. So what's the derivative of the top? What's the derivative of that x? It's 1, right? I'm concerned because no one else besides Bowman is saying. Do you remember that the derivative of x is 1? Okay. Just been a while. Just making sure. Minus. Now I'm going to plug in the bottom. So I'll get 3 times 2 squared plus 4 times 2. But I really don't need to do that because my next step is to multiply by bottom prime. Well, the bottom's a 2, which is a regular number. So what's the derivative of a number? It's 0. So what I end up with here is just 3x squared plus 4x because the rest of it is unnecessary. Questions on that one? Okay, you're about to ask something.
I was just going to ask, it's like fine, you can always change it to next.
I wouldn't use y.
Yeah.
I would use a different. You don't have to use t's, but I wouldn't use y. Are you avoiding t's because it looks like plus sign? Yeah. That's why I curve mine, but you could use whatever variable, just not y. Is that just 1 okay then? Alright, so if I look at 2, look at this space. It's really the same idea, and you might start realizing, like, I don't need to write this really. But your job is to plug in the top, so I'll get sine of x to the third, times the derivative of the top. Well, what's the derivative of x to the third? Somebody decides that. Look at that. I'm not even going to write the next one. Because my job is going to be plug in pi over 2. So it would be sine of pi over 2 cubed plus 3 times pi over 2 squared, which sounds horrible. But I don't really have to worry about it because then I'm going to multiply by bottom prime. Well, what's the derivative of any number? It's 0, so that whole second part will just go away. And that's your answer. So try it. Well, 3's a little bit here, but try it. Try 3. It's the same rule, it's the same idea. It's just presented a little different. So my job is to plug in the top. So if I plug the top in place of t, it would just say h of 4x. Like I don't know what to get when I plug in because I don't know what h is. But plugging in the top would just be, okay, h of 4x. Then I multiply by, so that's this piece, f of top. Then I multiply by top prime. Well, the derivative of 4x is 4. And then if I want to keep going, I can write the next step, but you'll see again that it cancels. So it'd be minus h of 1. So that's plugging, that's f of the bottom. But then bottom prime is 0. So this really just comes out to like 4 times h of 4x. How's that one? Okay. I look at 4, so I gotta erase this now. Well, I'll just worry about it. So if I do 4 up here, so my job is to plug in the top, which would be 5 times x, so that's f of top, times top prime. Well, the derivative of x is 1. Minus, remember this is not number 1, I'm doing number 4. Minus plug in the bottom. So this will be 5 times negative x times the derivative of the bottom. So what's the derivative of negative x? Negative 1. And like you could just leave it like that. I think some, like the AP test would probably rewrite it like this. Just like negative 5 times negative 1 is plus 5. But this is fine too. How's that one? Alright, try 5. If you haven't yet.
So you don't have to plug into the bottom if on the bottom of what you have. It's a constant.
Yeah. If it's a constant, you don't have to plug in because you're going to end up multiplying by 0. So some people treat that as like a separate rule. To me, it's easier to just remember one rule and like just process through it every time. But like at number 5, the bottom's not a constant, right? So you do have to do the whole. So you plug in the top. So plugging in the top would give me 3x squared minus 3x. And then I got to multiply, by the derivative of what I plugged in. So if I do that, did I just accomplish what I wanted? The derivative of 3x is 3, and I multiplied by 3. Is that good?
Well, that's only times the 3x.
Yeah. I want to multiply the entire thing by 3, so you need an extra set of parentheses there. Otherwise, you're only multiplying with 3x by 3. So just be careful about your parentheses with that type of thing. Minus, so plug in 2x, so 2x squared minus 2x. You want to multiply that by 2, but again, if I write it like this, I'm really only multiplying this piece. So make sure you have an extra set of parentheses there. And that's a perfectly legitimate answer. On the AP test, they might like square that and distribute the 3 and combine all the stuff. If it's multiple choice. But if it's free response, like you can just leave it there. How we doing? Go to work? You want me to do 20? Well. like how far over you are. But I want to find. I want to find the area. So I'm going to integrate from 0 to b. Because I don't know where b is. It could be like, okay. And I'm going to integrate that. So 1 minus cosine of x over x times dx. And all I'm doing there is just lining up. Those are the same variable. If this was t, that'd be t. So b is moving. So b increases at a rate of, so things are changing with time, which is when we get into like the dt thing. So this would be dp, db dt, because b is changing, would be pi over 2. With me there? Yep. So now I follow my rules. So I'm going to plug in b, which is going to be 1 minus cosine of b over b. But then I got to multiply by the derivative of what I plugged in, which is db dt. And then when I plug in the bottom, it's going to be like 1 minus cosine of 0 over 0, but it won't matter because I'm going to multiply by the derivative of that. So that second part will just wipe away. And then you just plug in, so b is now pi over 3. And then db dt is this pi over 2. You work that out. So like I would do this. Like if you multiply this, I don't know. There's probably different ways.
Can you just leave it as that?
Yeah, you can. But I don't know if Matthew's satisfied with that.
No, I'm just trying to do your circle without.
Oh, gotcha. Okay.
So my real question was, I guess I was just confused that you never took a derivative. I couldn't comprehend that we just have the derivative of
The dB dt.
Since I didn't actually take it, I guess.
Do you understand now where it comes from?
Yeah, I do, but even
I think looking at his work, because I looked at it,
because I was like, how is that?
like it looked like the dx dt turned into a dB dt,
Right,
and
that's
it's like,
what
but that's not really what happened.
Okay.
The dx goes away, and the dB dt like appeared because of the chain rule.
Okay,
It's not really
that makes
replaced.
more sense because I'm like, how do you get that? We didn't take it.
Yeah, yeah.
Okay,
Okay.
makes a lot more sense.
That would have been hard to read, right? I didn't know if you were just like, I don't know.
Oh no, I
Yeah.
I could not understand the argument of not taking the derivative, but when it's the same thing.
So we are most likely going to have an integral gateway, just like you had a derivative gateway. Where it'll be the same idea, like here's 10 things, you gotta take the integral of them. They're right or wrong, and then you get multiple tests. I think we have enough time. I'm just a little worried about finishing the material for the year, but I think we can do it. I think that gateway is super helpful, so I want to do it. You can leave multiplication, division, addition, subtraction. You have like anything else, trig or squares, so you gotta work them. How many of you guys lost power?